Hello, my name is Professor TK the Chemist, and I'm back with another video on radioisotopes. Now, we've had this wonderful discussion about what radioisotopes are, but now we need to go ahead and dig a little deeper in terms of what the word means when they say bombardment. If somebody is bombarding you, what does that mean? It's like they're coming at you, they're hitting you with so much information. But as it relates to chemistry, bombardment means to be hit or attacked with missiles, bombs, shell casings, all of that. But check it out. If we talk about bombardment as it relates to chemistry, there's also a connection with nuclear attacks, nuclear energy, nuclear chemistry. Okay, let's get into this lesson on how to actually write out a chemical reaction that deals with bombardment. Okay? So here in this example, they want you to write the balanced nuclear equation for the bombardment of nickel-58 by a proton, which produces a radioactive isotope in alpha particles. Now, you're probably wondering, what do I have to do with all of this information? Well, here we go. So let's go ahead and start this first example here. First thing they told you was that nickel-58 was bombarded by a proton. Now, let me give you the chemical symbol for a proton as it relates to chemistry. So we have 58, 28, nickel. Now, the 58 is what they told you the atomic mass was for this particular nickel, which tells me this is an isotope. And then the 28 is the atomic number. Now, they told you it was bombarded with a proton. This is the chemical symbol for proton, 1, 1, and H, okay? Then you're going to show what it actually produced or transmuted to once you have it being hit with an alpha particle also. So here's what we've got here. So it says it produces a radioactive isotope. That's what that box is for. And you're trying to figure out what all this means. Now, what I would do first is figure out what does the left-hand side equal to? Like, what are the amounts? Because they're going to have to balance out for both sides. So what I'm going to do, just simply write for my top number here on this left side, okay, 58 plus 1 gives me 59. And for the bottom number, 28 plus 1 gives me 29. So this tells me that the left-hand side has to equal to whatever is going to be on the right-hand side. So what I can do with this information is say that 59 equals what number plus 4? You know, like we've done before to find this missing piece here. So in order to do that, to find this missing top number, I'm going to subtract 4 from both sides. And 59 minus 4 gives me what? 55. Now for that bottom number, let's go ahead and solve for that. I've got 29 equals, well, let me space it down a little bit so you all can see even better. 29 equals what number plus 2? Well, I'm going to subtract 2 from both sides, and 29 minus 2 gives me what? 27. Now, I'm going to look at my handy-dandy periodic table to establish what that 27 relates to. Hold tight. Let me grab my periodic table. Guess what 27 represents? Cobalt. So this was the isotope that was produced. This radioisotope was cobalt-55. Stay tuned for our next example when we get into some more illustrations on half-life. Stay tuned.